Alright, so welcome to part 2 of the video, and I just need to talk to you about the isolated islands of Hawaii. Make it sound tropical and exciting. So why you guys need to know about Hawaii is because as an ecosystem, it particularly demonstrates why it's important for scientists to look at biodiversity, both in terms of the level of species in abundance, so that biodiversity index, as well as the level of genetic diversity, so that heterozygosity index. Okay, so this is a question that comes up all the time, and it's, why is it important? So the islands of Hawaii give a really good example and a really good basis for an answer as to why scientists have to look at both of those figures. You can't just look at one independently. So just to give a bit of sort of background idea on Hawaii, I'm sure you know, the islands of Hawaii are really isolated. They're 4,000 kilometres from the nearest continental landmass, so i.e. they're 4,000 kilometres away from mainland United States, and they're 1,600 kilometres from other islands. So they're quite remote, they are quite isolated, they're quite on their own in terms of geographical location. Now, Hawaii, their islands have a great deal of biodiversity in terms of species numbers. So to give you some examples, there are, I just pulled the wire. There are 1,000 different species of native flower found in Hawaii. There are 10,000 different insect species, and there are actually 1,000 different species of land snails. So when you look at their their biodiversity index, they're going to have a quite high one because they've got a high species richness. But before they were introduced, there were no reptiles and there was only one species of mammals, which is a bat. Okay, so whilst they have high species richness in terms of the organisms, the endemic organisms, they don't have a high species richness in terms of other things. They're quite limited in the type of organisms that they have. So they carried out DNA analysis of the endemic population, and it shows that they're all actually very closely related. So all these flowers, these insects, these land snails, etc., they're all closely related to each other, even though they look quite different. And actually it appears that there were only about 400 original species, so 400 ancestors from which all of these different snails, flowers, etc. have evolved from. So due to the isolated conditions, so Hawaii now is sort of in the middle of nowhere, because it was so isolated, it meant that a small group of found organisms, so these 400 original species, were able to adapt and evolve to take advantage of the ecological niches available. So they were able to evolve to fill in and be able to survive in that particular ecological scenario. So what this means is that places where endemism is common often have a rich biodiversity in terms of species number, but have a low genetic diversity, which is exactly what Hawaii is showing to you, okay? High species richness, but low genetic diversity. And so what this means is that they are really vulnerable to the introduction of disease. Okay, so this is why it's important that scientists look at both, because you might look at their biodiversity index, their species richness, their species abundance, and think, oh, it looks really, really good. But actually, when you check out the genetic diversity, these particular areas are really high risk. Okay, so Australia is a really good example of this and really good example of how they manage it. Australia are so strict about what you are allowed to bring into their country. Even dirt on the bottom of a shoe can be a problem. All right, so they're really, really strict and they monitor it really, really highly. When you land in Australia on the plane, you have to fill in a customs card and sort of declare all types of things, because they know that they're endemic species, they're native, flowers, plants and animals don't have this huge genetic diversity. So they're really at risk of any sort of pathogens and diseases that could be brought in from outside. Okay, so this is just to give you some context and an example to talk about if you're asked to explain why it's important that scientists look at both species number and abundance and genetic diversity. Okay, that's it from me. 2 videos for the lesson today. Please let me know if you've got any questions, but I shall leave you to it.